6 weeks before a critical IND submission, a peptide sequencing report came back with ambiguous fragmentation data on a semaglutide batch, and nobody on the analytical team could explain the discrepancy. That kind of moment doesn't announce itself, it arrives quietly, buried in raw MSMS output, and it can cost you months you didn't have. Hello, I'm Raghuveer Singh Parmar, Director Scientific Affairs at Resolve Mass Laboratories. We build the analytical workflows that help pharma and biotech teams answer these structural questions before they become regulatory problems. What is GLP-1 peptide sequencing? Let's start with what we are actually doing when we sequence a GLP-1 peptide like semaglutide. Peptide sequencing is not a quality check in the traditional sense. It's a structural interrogation, a systemic process of breaking a complex molecule into constituent fragments, measuring those fragments with precision and reconstructing the original sequence from the data. For a drug like semaglutide, which carries a fatty acid chain and multiple non-standard amino acid modifications, this is not a routine task. Every step of the workflow is a decision point. Sample preparation. The first step, sample preparation, is where most sequencing projects quietly succeed or fail. The principle is very simple. Dissolve your peptide in any LC-MS grade solvent. Remove salts, contaminants, or any other unwanted excipients from your product. Adjust concentrations and keep it cold. But the execution demands discipline. Semaglutide is hydrophobic at its acyl chain and must be handled at concentrations that prevent aggregation without sacrificing detection sensitivity. A less experienced team might spend weeks optimizing the instrument and never look back at the preparation, and that's precisely where the signal loss begins. Step number 2 is enzymatic digestion. Next comes enzymatic digestion. So this step converts the intact peptide into fragments the mass spectrometer can meaningfully resolve. The choice of enzyme trypsin is common but not always sufficient. The choice of enzyme determines what sequence coverage you'll actually achieve. With a molecule as modified as semaglutide, relying on a single enzyme is a calculated risk that rarely pays off. The fatty acid modification at lysine 26 creates a site that some proteases won't efficiently cleave, making that region analytically invisible. If you're not specifically designing around that, your coverage map has a blind spot you may not even know exists. We had a project where a team submitted a data showing high overall sequence coverage, close to 90%, but a regulatory reviewer came back asking specifically about C-terminal conformation. The data for those residues simply wasn't there. The digestion strategy had left the last few amino acids unresolved. A second enzyme combination run in parallel from the start would have closed that gap in the first pass is the kind of detail that becomes obvious only after you have seen it go wrong. LC-MS analysis. From there, the prepared fragments after enzymatic digestion enter LC-MS analysis. Liquid chromatography separates them by chemical properties. The mass spectrometer measures each with high precision. And the tender mass stage, the second analytical dimension, generates fragmentation patterns that reveal sequence order. Instrument resolution matters here more than most project teams anticipate. Low resolution data gives you masses. High resolution instrument give you confident, defensible identities. Understanding fragmentation data. This is really a little bit more complex. The fragmentation data itself, B ions and Y ions, is where the sequence gets reconstructed. Each ion type carries directional information. B ions read from the N terminus forward, Y ions from the C terminus back. Together they triangulate the sequence. Critically, modifications, the fatty acid chain, the AIB substitution at position number 2 appear as mass shifts, and those shifts only make sense to an analyst who knows what to look for and can distinguish a genuine modification from an instrument artifact. Now the question is why semaglutide is challenging. Semaglutide is analytically demanding for 3 interlocking reasons. First, its acyl chain modification changes chromatographic behavior in ways that affect both separation efficiency and ionization response. Second, the AIB residue at position number 2 is a non-standard amino acid, and many sequence databases tools aren't built to handle it without custom configuration. Third, the molecule's overall complexity means that achieving defensible sequence coverage requires careful engineering of the entire workflow, not just tuning instrument parameters. None of these challenges is insurmountable, but each requires deliberate design and not default settings. So let's talk about some of the best practices that can be followed. Okay, what constituently produces reliable results comes down to 4 disciplines. Use multiple enzymes to maximize sequence coverage across the full molecule. Validate findings with orthogonal techniques, not because you distrust your primary data, but because regulatory reviewers will ask and the answer needs to be ready. Maintain rigorous instrument calibration and throughout the run, not only at the start. And ensure that experienced analysts are interpreting the spectra. And the last point is consistently underestimated, and that is a fragmentation spectrum for a structurally modified peptide is not self-interpreting. The analyst's judgment is a functional part of the method. Here is what a well-executed sequencing workflow ultimately delivers. It confirms peptide identity and purity with structural evidence, not assumptions, not inference from synthesis records. LC-MS designed and executed correctly is the analytical backbone of characterization for complex modified peptides. And for a molecule like semaglutide, accurate sequence data isn't just scientifically valuable, it's what supports regulatory submissions with a kind of confidence that survives an FDA query. If your team is working on GLP-1 analog program or any other related peptide program for Health Canada or US FDA submissions and approaching structural characterization for the first time, or revisiting a workflow that didn't survive regulatory scrutiny, the sequencing strategy matters more than most teams plan for. And we have navigated these analytical challenges across multiple peptide programs, and conversation is always more valuable when it happens early. I would request to reach out to Resolve Mass Laboratories if you are facing any characterization challenges or you want our guidance on peptide characterization for US FDA or Health Canada. We would be happy to help you. Thank you so much for watching this session. See you in the next one. Until then, goodbye for now.